Hello everyone, my dear student. This is the fourth video of numerical from design of transformer from the subject electrical machine design. I am Professor PANKAJ from Department of Electrical Engineering, Sagar Institute of Science, Technology and Engineering, Bhopal. I have given you a numerical in my previous video lecture to solve, and in this video lecture I will be giving you detailed explanation with solutions of that numerical. The problem number 4 is determine the dimensions of the core, the number of turns, the cross section area of conductors in primary and secondary windings of a 100 kVA 2200/480 volt single phase core type transformer to operate at a frequency of 50 Hz. By assuming the following data: approximate volt per turn is equal to 7.5 volt, maximum flux density is equal to 1.2 Weber per meter square, ratio of effective cross sectional area of core to square of diameter of circumscribing circle is 0.6, ratio of height to width of window is 2, window space factor is equal to 0.28, current density is equal to 2.5 ampere per mm square. The key idea behind solving any kind of numerical problem is to read that numerical problem twice or thrice. That will give you idea how to start. First of all, we have to write the given data, which is 100 kVA 50 Hz, HW upon WW is equal to 2, it is given, 2200/480 volt given, ET is equal to 7.5 volt given, single phase transformer it is given, KW is equal to 0.28, and the ratio AI upon D square is equal to 0.6 it is given. Current density, which is represented by delta, is equal to 2.5 ampere per mm square. It is also given that it is of core type transformer, and the maximum flux density represented by Bm is equal to 1.2 Weber per meter square. Now let's proceed for the solutions. EMF per turn, which is represented by ET, is equal to 4.44 F phi m. From this equations, phi m is equal to ET upon 4.44, F is equal to 7.5 upon 4.44 into 50 is equal to 0.03378 Weber. Also, Bm is equal to phi m upon AI. Net core area, which is represented by AI, is equal to phi m upon Bm. Put the value, you will get AI is equal to 0.0282 meter square. It is given that AI upon D square is equal to 0.6. Hence, the core is 3-stepped core. Diameter of circumscribing circle, which is represented by small d, is equal to root under AI upon 0.6 is equal to root under 0.0282 upon 0.6. Solve this, you will get D is equal to 0.2168 meter. The kV rating of single phase transformer Q is equal to 2.22 F Bm AI KW AW delta into 10 to the power minus 3. Window area AW is equal to Q upon 2.22 F Bm AI KW delta into 10 to the power minus 3. Put the value, you will calculate AW is equal to 100 upon 2.22 into 50 into 1.2 into 0.0282 into 0.28 into 2.5 into 10 to the power 6 into 10 to the power minus 3. AW is equal to 0.038 meter square. It is given that HW upon WW is equal to 2. From this, HW is equal to twice of WW. Window area AW is equal to HW into WW is equal to twice of WW into WW, which is twice of WW square. From this, width of window is equal to under root AW upon 2 is equal to 0.0382 upon 2. calculate, you will get the result WW is equal to 0.1378 meter. Now the height of window HW is equal to twice of WW is equal to 2 into 0.1378. HW is equal to 0.2756 meter. Let 2200 volt be primary side and 480 volt be the secondary side. Secondary voltage Vs is equal to 480 volt. Also ES is equivalent to Vs. EMF per turn ET is equal to ES upon TS. Number of turns in secondary TS is equal to ES upon ET is equal to Vs upon ET is equal to 480 upon 7.5. Now the secondary turns coming to be 64 turns. The voltage ratio of transformer Vs upon Vp is equal to 480 upon 2200. Number of turns in primary Tp is equal to Ts into Vp upon Vs. That implies Tp is equal to 64 into 2200 upon 480 is equal to 293 turns. The kV rating of single phase transformer represented by Q, capital Q is equal to Vp-Ip into 10 raised to power minus 3 is equal to Vs-Is into 10 raised to power minus 3. Both equation is same, one is from primary side and one is from the secondary side. Now the current in primary side Ip is equal to Q upon Vp into 10 raised to power minus 3. Put the value in these equations. You will have Ip is equal to 45.45 ampere. Now the area of cross section of primary conductor AP is equal to Ip upon delta. You know the value of Ip and delta. Put this, you will get the numeric value of AP, which is the area of cross section of primary conductor. Current in secondary, that is 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 equal to Q upon Vs into 10 raised to power minus 3. Put the value, you will get Is is equal to 208.33 ampere. Now area of cross section of secondary conductor represented by As is equal to Is upon delta. You know the value of Is and delta. Put the value, you will get As is equal to 83.33 mm square. Now you can write all the results at the same place, just for the sake of examiner or anybody who is checking the solutions, like this. This is all about this numerical problem. Now I'm going to give you two more numerical problem for you. Consider it as assignment or practice questions. You have to practice it. This is similar to my previous lectures and also including this video lecture. You may not be able to solve it fully, but trying it will always be helpful to explore new ideas. Please refer my previous videos and attempt these questions. The first question is: a 300 kV 6600/440 volt 3-phase delta star core type transformer has a maximum flux density of 1.35 Weber per meter square and the total weight of core is 650 kg. The magnetizing VA per kg and the iron loss per kg corresponding to 1.35 Weber per meter square are 30 and 2.5 watt respectively. Calculate the no load current if the MMF required for joints is 2.5% of that iron. Assume other data needed. And the second question is: estimate the main dimensions of a 500 kVA 6600/400 volt 3-phase 50 Hz core type oil immersed self-cooled distribution transformer. Assume suitable data if needed. The data is written below. And this question has been asked in one of the universities of India. Just try these two questions, you'll be able to solve, I hope. Till then, thank you so much.